Namaste children, welcome back again. Hope you all doing well at home. In today's session, we will be discussing one of the most important topic of force and laws of motion, that is Newton's third law of motion. In the previous episode, we have been discussing about Newton's first law of motion, second law of motion. In the first law of motion, we have learned that how applied force changes the speed or velocity of an object. So, we have learned that the object remain in its state of rest or state of motion until it is compelled to change its state of rest or state of motion by applied external force. So, this is what we have learnt about first law of motion. In the second law of motion, we have seen how the applied unbalanced force causes impact on the object. This is what we have discussed about the second law of motion. So, force is equal to the applied force is equal to the product of mass and acceleration. In the second law of motion, we have learned that the applied force is very much depends upon the mass and velocity of an object. So, this way we measured how the applied force changes the motion of an object. In today's class, we will learn about Newton's third law of motion. According to this law, it states that whenever an object exerts force on other object, then the other object will exert equal amount of force on the first object. This is what Newton's third law is. Let us understand this law by taking an example. Here you look at the screen, here two balls are there, right? So, if the force is applied by the object A onto the object B, then what will happen? The object B also exerts force back onto the object A. Here suppose ball A exerts 5 Newton of force on ball B, then the ball B will exert equal in magnitude of force, that is 5 Newton of force back onto the ball A. But the difference is the applied force by the ball B onto the ball A is in opposite direction. Let us understand more clearly with another example. Here you see two spring balances. One end of the spring balance is attached to the solid support. When you drag, when you pull the other end of the spring balance, then you will see the reading in both the balances equal. When the first balance is pulled on that side and here the second balance exerts equal amount of force on that balance. Here you can see the spring is dragged in opposite direction. From this we can understand that spring balance A exerts certain amount of force on spring balance B. As a result of this, the spring balance B exerts equal amount of force but in opposite direction onto the spring balance A. So, this is what Newton's third law of motion. In our day-to-day life, we come across with various types of motions which are supported by Newton's third law of motion. For example, when you walk along a road, actually you are pushing the road backward. When you push the road backward, then the road exerts equal amount of force on your foot. When the road exerts equal amount of force onto your foot, then what happens? You are pushed forward. So, this way you are able to move along a road by pushing the road backward. So, here you will find Newton's third law of motion. So, whenever you talk about Newton's third law of motion, here two forces you will see which acts on two different bodies. Here the two forces are equal in magnitude but opposite in direction. These opposing forces which are acted on two different bodies are called action force and reaction force. The first force which is exerted on the first object will be the action force. In return, the second object exerts force back onto the first object, that is called reaction force. So, whenever we talk about Newton's third law of motion, there will always exist action and reaction force. The difference is the action and reaction force are held in opposite direction. So, this is what Newton's third law is all about. Now, we will see what is law of conservation of momentum. Let us understand conservation of momentum by taking example of two balls. Here you find two balls, ball A and ball B. Let us assume that ball A has mass m. So, here mass of ball A is ma and mass of ball B is mb. Let us assume that these two balls are moving in a straight line in the same direction along a same path. Let us assume that ball A of mass m moves with the initial velocity of ua. Similarly, ball B is also moving with the initial velocity, here we take it as ub, and both the balls are moving in a same direction. Let us suppose the initial velocity of object A is greater than the initial velocity of ball B. When these balls are in motion after traveling certain distance, what will happen? Since the velocity of ball A is greater, as a result of this, what happen? After traveling certain distance, ball A will collide with ball B. When A collides with B, for some time, we can take the time as t. When the ball collide with ball B, then at that point what will happen? Force will be exerted on ball B. So, this force can be written as FAB. This indicates that during collision, force is exerted on B. From the third law of motion, we know that an equal amount of force will be applied back on the object. So, when the ball A collides with B, it applies force on ball B. Similarly, ball B exerts an equal magnitude of force on ball A, but it is in opposite direction. Now, we consider that the applied force by the ball B towards A is FBA. The direction of force applied by ball A to ball B will be this direction, whereas the equal amount of force applied by ball B to ball A will be indicated by this direction. After collision, the ball A and B both will acquire final velocity. After collision, the velocity acquired by ball A can be written as VA, and after collision, the velocity acquired by ball B can be written as VB. Here the total momenta before and after collision of ball A can be written as MAUA is the momentum of ball A before collision. After collision, then here MAVA. Similarly, the total momenta before and after collision of ball B can be written as here MBUB. After collision, the momentum will be MBVB. Change in momentum can be written as MAVA minus MAUA. Similarly, the rate of change of momentum is equal to MAVA minus MAUA divided by time, right. Here the rate of change of momentum is the force applied by the ball A towards ball B, right. So, FAB is equal to, we can write MAVA minus MAUA divided by time. Similarly, we can find the rate of change of momentum for ball B. F, force applied by B on A, can be written as MBVB, here final velocity, minus MBUB divided by time. We have learnt in third law of motion that for every action there will be an equal and opposite reaction. So, ball A is the action force and ball B will exert an equal but in opposite force on ball A. Mathematically, it can be expressed as FAB is equal to FBA. Here minus sign we have to add because this is the force exerted by ball A on ball B. Equal amount of force will be applied by ball B on ball A, but in opposite direction. So, opposite direction can be indicated by negative sign. Substituting these values, what we will get? Here we will get MA VA minus UA divided by time, which is equal to minus MB VB minus UB divided by time. On rearranging this equation, here T and T gets cancelled. So, finally, we will get MA VA minus UA is equal to minus MB VB minus UB. So, on further solving this, we will get MAUA plus MBUB is equal to, and this goes this side, then here MAVA plus MBVB. From this expression, you can see this is the momentum of ball A this is the momentum of ball B, right. So, the total momentum before the collision, this is the momentum of ball A after collision, this is the momentum of ball B after collision. Here you can see very well that total momenta of the ball A and B before collision is equal to the total momenta of two balls after collision. There is no change in momentum before and after collision, which means the total momenta of the two balls before collision is equal to the total momenta after collision. We can see the momenta of object before and after collision is unchanged. So, we can say that the momenta is conserved by collision. So, this is what law of conservation of momentum is. Look at the question. A bullet of mass 20 gram is horizontally fired with a velocity of 150 meter per second from a pistol of mass 2 kg. What is the recoil velocity? You have to understand what is recoil velocity here. When the bullet is fired, then the bullet will go this direction. When the force is applied on the bullet moves forward direction, and an equal amount of force will be exerted on the pistol. As a result of this, the pistol will move backward direction. So, this backward direction, the force applied on the backward direction of the pistol recoils it. This is called recoil velocity. So, in the question what is asked, when the bullet is fired, then it goes with a certain velocity. According to third law of motion, we learned that when a force is applied on an object, an equal amount of force will be applied back on the object in opposite direction, right. So, if force is applied back on this pistol, then it will have some velocity. What will be the velocity? That we have to find, that we call it as recoil velocity. Let us see how this numerical problem could be solved. So, firstly we write whatever the physical quantity is given in the question, we take it as mass of the first object 1. So, here we write m1, m1 is the mass of the bullet, we just write bullet is equal to 20 gram. The mass is given in gram in case of bullet, whereas in case of pistol you see in kg. So, always mass should be expressed in kg. So, by converting it into kg, this will be 20 by 1000 kg, right. So, finally we will get 0.02 kg. Now, m2, what is our mass 2? Here mass 2 is the pistol we take, right. Here mass of the pistol is 2 kg, we write as it is. Before firing, the velocity of bullet and the pistol is at rest. So, initial velocity we take it as 1, as bullet is 0 again. Here u2 is the velocity of pistol before firing. So, here also 0 meter per second since both are at rest. After firing, the bullet acquires some velocity, that we take it as v1. v1 is equal to 150 meter per second as per the question. v2 is the velocity acquired by the pistol in the backward direction, that we need to find, that is the recoil velocity, we say recoil velocity. So, the things what are given in the question that we have already written. How can we do this numerical problem? First we will see the momenta, plural form of momentum is called momenta. Firstly we will find the total momenta of bullet and pistol before firing. So, that we write first. The total momenta of pistol and bullet before fire, we will take it as P1. We know that P is equal to mv. To find the total momenta, we take it as P1 before firing, which is equal to m1 into u1 plus m2 into u2. Look at very carefully, here m1 is the mass of the bullet and u1 is the initial velocity of the bullet, that is before firing. Similarly, here m2 is the mass of the pistol and u2 is the initial velocity of the pistol. Here both the velocities are before firing. By substituting the values, we will get here m1 we know that 0.02 kg multiplied by initial velocity is 0, plus m2 we know that it is 2 kg multiplied by initial velocity of the pistol is again 0. Here this is the momentum of the bullet before fire and this is the momentum of the pistol before fire. When we add the momentum of both bullet and the pistol, then we will get the total momenta of pistol and bullet before fire. This will become 0 kg meter per second, right. Now we find the total momenta of pistol and bullet after fire. So again the same formula we can use, P is equal to mv, right. So here P2 we will take as the total moment of pistol and the bullet after fire. So this can be written as m1 v1 plus m2 v2. Here m1 is the mass of bullet, that will be 0.02 multiplied by final velocity of the bullet as given in the question, 150 meter per second, right. So here 150 meter per second plus here m2 is the mass of the pistol is given as 2 kg multiplied by final velocity we don't know. This is the recoil velocity which we need to find. Okay. So solve this equation, P2 is equal to, on multiplying this we will get 3 plus 2v will be our answer, right. So here P2 we have got. Here 3 plus 2v, what we have obtained is the total moment of pistol and bullet after firing. So we have got total momenta after and before the fire. So according to the law of conservation of momenta, we know that the total momenta of pistol and the bullet after fire will be equal to the total momenta of pistol and bullet before fire. So here we can write as P2 is equal to P1. Here P2 is the total momenta of pistol and the bullet after fire, and P1 is the total momenta of pistol and bullet before fire. So substitute the values. Here we will get 3 plus 2v is equal to 0. Upon solving this we will get 2v is equal to minus 3. So v is equal to minus 3 by 2. Finally we will get minus 1.5 meter per second. Here you see negative sign, right. Here the negative sign indicates that the direction of this velocity is opposite to the direction of velocity of the bullet. That means here the velocity is in this direction at 150 meter per second after firing. If the velocity is in this direction at 150 meter per second, then the velocity acquired by the pistol is in opposite direction. It is 1.5 meter per second its velocity, but its direction is opposite to the direction of the bullet. So this way we can understand the negative sign in the recoil velocity. So when a bullet of mass 20 gram is horizontally fired with a velocity of 150 meter per second from a pistol of mass 2 kg, then the recoil velocity will be 1.5 meter per second in the opposite direction. Look at the second numerical problem. A girl of mass 40 kg jumps with a horizontal velocity of 5 meter per second onto a stationary cart with frictionless wheels. The mass of the girl is 40 kg. The mass of the cart is 3 kg. What is her velocity as the cart starts moving? Assume that there is no external unbalanced force working in the horizontal direction. Look at the question very carefully. Here mass of the girl is given and the girl is jumping with a velocity of 5 meter per second. So initial velocity of the girl is given. A stationary cart, here stationary cart means the initial velocity of the cart will be 0. The mass of the cart is already given as 3 kg. When the girl jumps over the cart at a velocity of 5 meter per second, then the cart will move, right. When the cart starts moving, at that point what will be the velocity of the girl? So how can we do? Let us write the quantities given in the question. Here m1 is equal to 40 kg we will take. Here m1 indicates girl. The initial velocity of the girl u1 is equal to 5 meter per second, which is given in the question, right. Then here m2 is the mass of the cart. Mass of the cart is 3 kg, that also we can write. The initial velocity of the cart will be 0 since it is at rest position. Final velocity of the girl, v1 indicates girl, final velocity of the girl we need to find, right. Firstly we find the total momenta of the girl and the cart before interaction. We know that P is equal to mv. Before interaction we mention it as P1 is equal to, before interaction the momentum of the girl we write as m1 u1 plus the momentum of the cart, that is m2 u2. We have m1 as 40 kg and initial velocity of 5 meter per second, right, plus mass of the object is 3 kg into 0. So, the entire term gets 0, right. So, here we write 4 5s are 20. So, we will get 200 kg meter per second. So, this is the total momentum of the girl and the cart before interaction. Now, we see the total momentum of the girl and the cart after interaction. In a similar way, what we have done earlier, we take it as P2, here 2 is the total momentum after interaction, is equal to m1 v1 plus m2 v2. Here you see v1 will be equal to v2. Why? Because when the girl jumps over the cart, then the cart will move. So, the velocity acquired by the girl and the cart both will be same. So, the velocity of the girl is the velocity of the cart, right. So, here v1 is equal to v2 we can write. So, by substituting this we will write then p2 is equal to m1, we know that it is 40 multiplied by v1 plus m2 is 3 kg multiplied by p1 is equal to v2. So, we can write here v1. Okay. So, p2 is equal to 40 v1 plus 3 into v is 3 v1. By taking common we will get p2 is equal to v1 here 40 plus 3. So, this is the total momenta of the girl and the cart after interaction. According to law of conservation of momentum, we know that the total momentum of the girl and the cart after interaction must be equal to the total momentum of the girl and the cart before interaction. So, we can write P2 is equal to P1. Substitute the values, we will get P2 is V1 40 plus 3, which is equal to 200. Here we will get V1 is equal to 200, 40 plus 3 is 43. Upon solving this, we will get 4.65 meter per second. So, this way the numerical problem could be solved. So, the velocity acquired by the girl on jumping on the cart will be 4.65 meter per second. Look at this question. Two objects of masses 100 gram and 200 gram are moving along the same line and direction with the velocities of 2 meter per second and 1 meter per second respectively. They collide, and after collision the first object moves at a velocity of 1.67 meter per second. Determine the velocity of the second object. Now, let us understand this question first. This is object A and this is object B. A is with mass 100 gram and B is with mass 200 gram, and both are moving in a same line in a same direction. This direction we assume. Object A moves with a velocity of 2 meter per second and object B moves with a velocity of 1 meter per second. So, when both the objects are moving in the same direction, you see object A moves with a greater velocity, that is 2 meter per second, than object B, which is 1 meter per second. When they move in the same direction, naturally after traveling certain distance, object A will collide with object B. On collision, the first object moves at a velocity of 1.67 meter per second. This object moves with a velocity of 1.67 meter per second after collision. Now, the question is, if object A moves with 1.67 meter per second, then after collision what will be the velocity acquired by this object? This we have to find. Firstly, we write the given quantities. First we write MA, this is the mass of the first object, which is equal to 100 gram. So, we have to convert it into kg. So, we will have 0.1 kg the mass of first object. Secondly, we write MB, here mass of the second object is 200 gram, right. So, 200 grams, when we convert it into kg, then we will get 0.2 kg. Then the initial velocity of both the objects are given. Here UA is equal to 2 meter per second, whereas UB is equal to initial velocity of object B is equal to 1 meter per second, which is given in the question. Now, after collision, object A produces the velocity of 1.67. So here we write VA is equal to 1.67 meter per second. Here we take P1 is the total momenta of both the balls before collision. So P1 is equal to, we have M1 U1 plus M2 U2. Substitute the values. By substituting the values, what we will get? MA is 0.1 into UA is 2 plus MB is given as 0.2 multiplied by UB is given as 1 meter per second. So here we will get 0.2 plus here 0.2. Then we will get 0.2 plus 0.2 is 0.4. So this is the total momenta of ball A and ball B before collision. Now we find after collision. So this is the total momenta before collision. Now we write after collision. Total momenta after collision. So here we write after collision as P2 is equal to MAVA plus MBVB. Substitute the values. MA we know that 0.1 into VA is 1.67 plus MB is 0.2 multiplied by VB we need to find, right. So which is equal to here 0.167 plus 0.2 VB. So this is the total momenta after collision. So according to law of conservation of momentum, we know that the total momenta of the two objects after collision will be equal to the total momenta of the objects before collision. So here we write P2 is equal to P1. Here P2 is 0.167 plus 0.2 VB is equal to 0.4. Upon solving this, 0.2 VB is equal to 0.4 minus 0.167. So here VB is equal to 0.4 minus 0.167 divided by 0.2. On subtracting this, we will get VB is equal to 0.233 divided by 0.2. Finally, we will get 1.165 meter per second. So this is our required answer. When the first object of mass 100 gram hits the second object of mass 200 gram, then after collision, the velocity acquired by the second object, that is having 200 gram, will produce velocity of 1.165. Here plus sign indicates the direction of velocity is with the direction of motion in which the object B was moving. This way the numerical problem could be solved. So dear students, we have come to the end of this chapter, force and laws of motion. Hope you understood this chapter. If you have any doubts or queries, you can contact us. So with this, I would like to conclude today's session. Before concluding, I would like to give some easy home assignments which you can practice at home. So here is your home assignment. I believe you will find all these home assignments very easy. See you all on another day with a new topic. Till then, take good care of yourself.